What if I told you the most complex object in the universe can be described using just three numbers? Everything you are, every atom, every memory could fall into a black hole and be reduced to just three numbers. Black holes swallow stars, planets, and even light. But do they also destroy information forever? Now, how many numbers describe the moon? Think about the moon. It has thousands of craters. Each crater has a location, latitude and longitude. Each crater has a size. That alone means thousands of numbers. Now add surface chemistry, rock composition, temperature variations, elevation differences. Very quickly you need millions of numbers just to describe one moon. Now imagine describing a planet, a star, a nebula. It would take an unbelievable amount of data. But now comes the shock. The simplest object in the universe, a black hole, the most extreme object in the universe, needs only three numbers. Just three. No matter how big it is, where it formed to it. You only need number 1, mass, number 2, electric charge, and number 3, spin, angular momentum. That's it. This idea is called the no-hair theorem. Black holes have no extra features, no memory, no details, just three numbers. But how is that possible? Where did all the information go? Imagine throwing into a black hole books, computers, entire libraries, even all human knowledges. Once it becomes a black hole, all that information is reduced to mass, charge, spin. So what happened to the rest? Did the black hole erase it? This question became one of the biggest mysteries in physics, the black hole information paradox. The first idea of a black hole back in the 1780s, a scientist named John Michael had an idea. He asked, what if gravity were so strong that even a light could not escape? He used Newton's physics and calculated something called escape velocity. For Earth, about 11 km per second. For the Sun, about 617 km per second. But what if escape velocity was greater than the speed of light? Then light could not escape. That would create a dark star. This was the first idea of what we now call a black hole. Einstein changes everything. In 1915, Einstein introduced general relativity. Soon after, Carl Schwarzschild found a solution to Einstein's equations. He discovered something incredible. There is a special radius now called the Schwarzschild radius. Inside this radius, nothing escapes, not even light. This boundary is called the event horizon. Once you cross it, there is no return. The shocking discovery: black hole have temperature. For a long time, scientists believed black hole were completely black, but in the 1970s, something unexpected happens. Physicist Jacob Bekenstein suggested black holes had entropy. Stephen Hawking made a revolutionary discovery. Black holes emit radiation. Today we call it Hawking's radiation. That means black holes are not completely black. They slowly lose energy, they slowly evaporate. And here is something even stranger. Big black holes are cold, small black holes are hotter. Completely opposite to normal objects. How does Hawking's radiation works? Quantum mechanics says empty space is not truly empty. Tiny particles pair constantly appear and disappear near the event horizon. One particle falls into the black hole, the other escapes. The escaping particles become Hawking's radiation. The black hole loses a teeny bit of energy. Over billions and billions of years, the black hole evaporates. But this creates a huge problem. The information paradox. If a black hole evaporates completely, what happens to all the information that fell inside? Quantum physics says information can never be destroyed. But Hawking radiation looks random. It carries no clear information. So is information lost, or is it hidden? This question puzzled scientists for decades. The holographic principle. Then physicists discovered something extraordinary. Black hole entropy depends on its surface area, not its volume. That is strange. Normally, entropy grows with volume, but for black holes, entropy grows with area. This leads to holographic principle. It suggests all the information inside a region of space may actually be stored on its boundary, like a hologram. Maybe our entire universe works this way. Maybe reality itself is like a cosmic projection. What is inside a black hole? We still don't know. We cannot send probe inside. Nothing can escape. But in certain string theory models, scientists had counted microscopic states of special black holes. In those simplified models, the math matches Hawking's entropy formula perfectly. That gives us hope. But for real black holes like Sagittarius A, TON 618, we still don't fully understand their interiors. So the final thought is black holes are the simplest object in the universe, the most mysterious object in the universe, the bridge between gravity and quantum physics. They challenge our understanding of space, time, information, reality itself. Almost 3 years after they were first imagined, black holes remain the greatest cosmic mystery. And maybe one day they will reveal the true nature of the universe. If black holes can reduce everything to 3 numbers, what does that say about reality itself